So hello everyone, in this video we are going to discuss a real life case study based on a ANOVA method. So anybody having a problem statement?
Yes ma'am. So let us take a problem statement on agriculture land. So an agriculturist wants to test the effect of 4 different fertilizers A, B, C and D on the field of paddy. So in order to eliminate the source of errors due to variability in self-fertility. So given below where the numbers indicate fields of initial per unit area. Perform an analysis of variance to decide whether there is difference between the fertilizers at 5% of level of significance. So the table is A18, D22, B15, C22, C21, B12, A20, D21, D25, A15, C23, B10, B11, C19, D24 and A17.
So here in this given table, it is a 4x4 table. So in which we are going to first decide which method we are going to use. So since here in this content there are 3 sources of variations. So one is farmers, next is menus and the yield. So we are going to use a Latin square method for this problem.
So let us solve this problem using Latin square method. By default, by seeking of given, we defaultly put a null hypothesis and alternate hypothesis. From the given, null hypothesis will be mentioned as there is no difference between fertilizers, since null hypothesis were not significant, and alternative hypothesis H1 whereas there is a difference between fertilizers, so it is significant. So we are defining based on that, and we define both hypotheses. By given, they have given the difference between the fertilizers as 5% of level of significance. So in this level of significance, the alpha is equal to 5%, 0.05. So by the given, it has 4 fertilizers. So the table have 4 into 4. The n will be
totally there are 16 data, so n is equal to 16.
And there will be 4 fertilizers, so small n will be 4. And to find CF is equal to
CF, correction factor.
CF is equal to T square by n. To find T, we have already checked n, but we need to find T. From the given,
T is nothing but the total of the entries. So we have to add all the 16 entries.
By adding 16 entries, it will go a large number. So by simplification method, we get 18 by large number plus small number divided by 2, and after getting that number, we subtract from each table, and we will add all the data. By adding all the data, T will be 7. So by substituting in this CF, so T square will be 7 square will be 49 by n will be 16. So 49 by 16 become 3.062. It will be here. And after subtracting 18 to the table will be rearranged. So after rearranging, we will put entries to shift the origins. So let us keep the x1, x2, x3, x4 and y1, y2, y3, y4. After this, rearranged values will be placed here, and will be total, which is x1 summation, x2 summation, x3 summation.
The column totals will be taken as summation x1s. Next row totals will be taken as summation y.
Then x1 square, x2 square, x3 square and x4 square were respectively calculated and taken summation of them.
So now the calculation of sum of square of columns and rows will be explained by Sanjay.
TSS, total sum of the square. Now find the formula of the summation of x1 square plus summation of x2 square plus summation of x3 square, summation of x4 square minus CF. Find number 41 plus 58 plus 147 plus 87 minus 3.06. The final answer is 329. Next, SSC. The formula of the summation of x1 square whole square divided by c1 plus summation of h2 whole square 2 divided by c by 2 plus summation of h3 divided by c by 3 summation of h4 divided by c4 minus cf. By substituting the value, final answer 4.6875. Next.
So similarly, using in the place of summation x1s, we will substitute y1s, and in the place of columns, we will substitute r, so that we get the SSR value. Sum of the square of rows as 29.19. So now Mithul is going to explain the treatments part.
So firstly, you have write A, B, C, D. So then with help of previous table, you can find the values. Like in the first row and first column, they have given A18. So with help of that, we can find the value, and we'll put 0.
We can rearrange the table in such a way that first row is fixed with A,
And second row is fixed with B,
C
third row is
and D. So on the summation part, we'll get summation Z1s.
So in second, we can say that A20, so we can put the number 2, and similarly we will fill all the data. Like after that, we have to total like A parts, and we have to find the summation of Z, and B parts and summation of Z2 square, and C parts and summation of Z3 square, and D part to get summation Z4. So while coming to sum of square of treatments, we have formula like summation Z1 square divided by 4, that is C, that is number of treatments. Sorry. Then summation of Z2 square divided by 4, then summation of Z3 square divided by 4, then summation of Z4 square divided by 4. After doing this, we will get a value that is 284.19. Then SSC, that is sum of square of error. So by doing all TSS, SSC, SSR and SST, we will get a value, and we have to separate all the values to get SSC. Thank you.
From all the process, we can find the source of variations between rows, columns, treatments and errors. We can find the degree of freedom, sum of squares, mean sum of squares, F ratio and F alpha. Thank you.
So the sum of the squares are the values which we have found in the prior. Next, mean sum of the squares is nothing but the sum of the squares divided by our degrees of freedom. Next, F ratio is always greater than 1. So it should be framed in such a way that the greatest value comes in the numerator and the rest in the denominator. So how will you conclude this? So if the F ratio is greater than the F alpha value, we will reject H0. If the F alpha is greatest, we will accept the
H0.
So in this case, what is happening? So it's nothing but we are rejecting H0 in all the cases, like in between the menus, between the fertilizers and between the treatment also, we are rejecting the null hypothesis. So there is a difference between each and everything. Thank you.
Thank you.